Okay, this is the next question. In triangle ABC, we have angle BAC to be equal to pi over 6, and BC is equal to root of 7, and AB is equal to 4. We are asked to find AC. So let us draw the triangle. So this is A, B, C. Side opposite is A, this side is B, this side is C. Now we are being given B, A, C. This is pi over 6. That's 30 degrees. Okay. Alright. So pi over 6 is 30 degrees. Now AB, the distance of AB is given as 4 units. BC, this is given as a root of 7 units, and we have to find AC. So by cosine rule, what you got? B squared is equal to, we have got only this angle, right? So we will have to include this angle. So we cannot write a statement for B squared, right? So what I'm going to do is I will have to take in this. Okay, if I take in A squared is equal to B squared plus C squared minus 2 times B times C times. So these two sides are under consideration. Is equal multiplied with cos of the angle between them. That's pi over 6. So A squared is root of 7 squared. B squared we don't know. C squared is 4 squared. Negative 2 times B is not known. C is known. Cos 30, right? Cos 30 is root 3 over 2. This is nothing but cos 30. So root of 3 over 2. So 2 divides here 2 times. So you have B squared plus 4 squared minus 4 times B times root of 3. So that has to be here. So 7 squared is 7. So what we have to do is we will have to bring 7 negative. This quantity is 16 is equal to B squared negative 4 times the root of 3 times B. This is what we've got. Okay, so I'm going to rewrite this as B squared negative 4 times the root of 3B is equal to, now 7 negative 16. That's going to give me a negative 9 there. I push this negative 9 to the other side. So this is going to be a positive 9 is equal to 0. Okay. So this is a quadratic in B. So I use quadratic formula. So the pattern of the quadratic is considered as x squared, right? So I'll write as ax squared positive bx positive c is equal to 0. So a is 1, b is negative 4 into root 3, and c is equal to 9. So the formula is negative b, right? So my b value is negative 4 times the root of 3 plus or minus root of b squared. B squared is negative 4 times the root of 3 squared, negative 4 times a is 1 and my c is 9 divided by 2 times of a is 1. So This is 16 times root of 3 is 3. 18, 6 3s are 18, 1 3, 1 3, 48. This is 9 4s are 36. So you have a 2 and a 12, right? So from 48 you take away 36, you get a value of 12. So this is going to be 4 times the root of 3 plus or minus root of 12 divided by 2. So this is going to be 4 times the root of 3 plus 12. I can write 12 as 4 times 3, root 3. So this is going to be, when I square it, you have 2 times the root 3. So 2 times the root of 3 divided by 2. Of course, there's a plus and minus there. So if I were to take 2 times the root of 3 out, I would have a 2 here, and plus, right, plus 1 will be there, isn't it? So 2 into 2 is 4, 4 times the root 3, and I have a plus 1 there for this component, divided by 2. This is for the positive sign. So 2 and 2 gets cancelled. 2 plus 3, or I would say 2 plus 1 will be giving me 3. So you have 3 times root 3. This is one value. Now there is this other value. So b is equal to one value. The other value is negative sign. So I take 2 times the root of 3 out. It's going to give me 2 minus 1 divided by 2. Fair enough. 2 and 2 gets cancelled. You get root 3. So two values are occurring here. So b is equal to 3 times the root of 3, and b is equal to root 3. Okay, so what can you say about the uniqueness? Now this question is an example for SSA ambiguity. Now what does it mean, SSA ambiguity? Side-side angle ambiguity. We are getting two values for b. Now both the values are perfectly valid. Now some people might be talking about uniqueness. Okay, and they will try to pick one of this. That is incorrect, because the geometry under consideration here did not earn that uniqueness. Okay, so both these values are perfectly applicable and perfectly they are attainable. So that is a beautiful example of where ambiguity comes into the element of geometry. Okay, so let's move on to the next question, having seen this.